So while I've got our solution to regular cooling up here, let's expand it a little bit. So by expanding it, I might use yet another crap assumption, which is that if my cup of tea were in fact a 200-gallon drum of tea, it would probably warm the room up a little bit, right? Is there a net energy gain or loss in the room?
No.
Probably not.
Yeah.
Right? I mean, actually, this room has windows, right? And so depending on the amount of water and how hot it was, we would probably lose some heat to the outside. And then we would have yet a third set of assumptions, right? But let's just make one more. So the one more assumption we could make to improve on this is that net energy loss is 0. Okay? And this is not my specialty, but I'm going to assume that this equation, that should be a K. So I have K times the difference in temperature between where my object is and where it started, right? Plus K for the room. Oh, I guess I was using E for this, wasn't I? And then something like the temperature of the room minus the temperature that the room started at is 0. Okay, so assume that this represents the energy in the room is conserved. If you wanted to write this down, like if you wanted to develop this really precisely, you would end up thinking, okay, so K is kind of the energy inertia of the cup of tea. KE is kind of the energy inertia of the room. And the amount of energy lost by the tea plus the amount of energy gained by the room should be 0. Right? In other words, the energy comes out of the tea and goes into the room and doesn't go anywhere else.
So should that be a negative K on the first one?
Not according to my notes.
Well,
But
your signs of your
if we did
coefficients.
this, maybe that would make more sense.
It all
Yeah.
depends on on whether your K is
Yeah,
negative by
Yeah,
you know.
okay.
So in the other situation, I would maybe be saying the opposite, right? The energy gained by the cup of tea is the energy lost by the room, but it doesn't matter either way,
Yeah.
right? You guys see that? Maybe it would be most clear if I wrote this down as KT minus T0 equals minus KE TE minus TE0. That'd be most clear?
Yeah.
The energy gained by the cup of tea is the energy lost by the room. The energy lost by the cup of tea is the energy gained by the room. You guys all cool with that? One of these algebraic manipulations is true. Probably. Up to physics. I don't know physics. Yes. Okay, but we can improve our model using that thought. How can I improve my model using that thought? Like this is the thing I have, right? This is my solution. This guy solved Newton's law of cooling. That guy is apparently also a reasonable assumption. Do I have to go back and re-solve this whole thing?
Can we just make TE a function of time as well?
Dude, that seems like a great idea. It probably better be, right? You guys see that? So if I go over here and think about which things are constant, right? You guys see that? Like, this thing's not constant. That thing is. That thing's constant. That thing's constant. That one's not. And that one is. You guys with me on that? So, I could probably just, like, cheat like mad. Right? Like, the dumbest thought I could have is, like, maybe I can solve one of these things and cram it into one of the others. You guys see that? Is that necessarily a good assumption?
Mathematically,
I have no
sure.
idea.
Starting place.
Yeah, it's a good spot to start, right? So I did make one assumption when I was differentiating this thing, right? The assumption I made when I differentiated this thing to get t prime, to shove it in here and calculate, was that te had a derivative of 0. You guys see that? I'm just slightly scared that's going to cause me problems. You guys with me on that?
Yeah.
That's a reasonable thing to be scared of. But I don't know. I'm just going to guess. And this is the philosophy I want you to take from differential equations. Do not get hung up on knowing exactly the right technique for a given problem right away. Try something and see how close you get. Then revise your guess. That said, I am going to give you a bunch of techniques as we go. Those techniques are hella useful to know because they're the right ones and you won't waste much time. You guys see that? But if you don't know a technique right off the top of your head, try something. So what I'm going to try for this something is I'm going to say, oh heck, I don't know. Let me solve for TE. Right? And then I'll plug it in over here and then maybe I'll differentiate and see if it worked.
Wouldn't we get some kind of recursive thing, because it depends on t, and t depends on te, and vice versa?
Yeah. But I think I know what T is. Like, I feel like I have a good guess. T is probably this stuff. You guys see that? I'm not sure this is going to work. Like, to be really honest, I haven't worked all the way through this example in a couple of years. Let's see. It'll be fun. So, I think I want to solve for T. So I've already kind of got that almost done it, right? So what else do I need to do to solve for TE?
Divide by ke and
Okay, let's divide by ke. So we got minus k over ke times t minus t0 equals te. Oh, what the heck? Let's do plus te0 equals te. Cool. Now, yeah, probably try plug te in over here.
And twice.
And there.
Then we'll have t equals,
Yeah, and then I'll have t equals, so I'll have to solve for t again. You guys see this? Is this guaranteed to work?
no?
No, and I'm concerned because I did that when I took the derivative of te, I assumed it was 0 thing, right? Is this the best I've got for right now? Yeah, probably. Okay, so let's try it. Let's see what we can do. So we're going to plug te in. And so my best guess is that t as a function of t is t0 minus all this crap. So that's going to be plus k over ke t minus t0 minus te0. Woof. Did I do that right? Take this thing, subtract it.
Yeah.
So I got plus that part and minus that part. And then I got e to the minus kt. Oh, and I probably should take the of t off of this because I'm going to have to solve for it.
Plus just, or minus that.
And I got plus this whole business, right? So I got a, I suppose, minus k over ke. Oops. That handwriting. Okay, little e. T minus t naught minus plus te0. Cool. Okay. So now,
Simplify.
yeah, now you simplify a little bit, right? So my goal is to group all the t's on one side and all the other stuff on the other side. Which is why we make you guys take hella lots of algebra, right?
Yeah.
Because, yeah, this is freaking messy, right? How many variables you got in this thing?
I haven't seen a number in so
Like
long.
5 or 6, right? Yeah, there's not
Go
a,
back to that.
there's there's maybe one thing that you could kind of call a number, like an honest number in this thing, which is what?
The plus
E.
T, 0.
Or-
Like the initial temperature.
E's a number.
I was thinking of E. Like E is a number for sure, right? Otherwise, everything else in here is parameters or variables, right? Or actually functions. So this takes a minute. But we can do this. What time do I have? Oh, I only have till now.
Yeah.
Cool.
Until a minute ago.
Okay. Exercise. Solve this the rest of the way.
All right.
So I'm just